All right, so something to think about as we're doing these. Yes.
Dude,
Oh, you want to answer it? Well, hold on. When they say the figure's not to scale, that's kind of something, whether they say it or not, you kind of want to think about. Remember, there's a lot of things that we cannot state about looking at a picture. And a lot of people get answers, and they say, well, the picture doesn't look like it should have a 60-degree angle there. It looks more like maybe a 45-degree. They're not drawing things with a protractor. They're not trying to find the answer. They're drawing the picture that goes with that problem with a protractor to make sure that the answer matches the picture. Does that kind of make sense? Yeah. So make sure that you understand that. This one, for some reason, they put figures not to scale, but usually they don't write that, and we just want to assume that they're usually not to scale.
Yeah.
All right, so what is the approach here? Yes.
That the two code things equal the outside.
Okay, so which one's the exterior angle then?
The 16.
Okay, so 16x plus 10 is my exterior angle, and then the remote interior angles, remote meaning the ones that are far away, right? The ones that are separated or detached from 16x plus 10. So it'd be those two angles, right?
Yeah.
So what are we going to do with those? Add them together. So I get 10x minus 4 plus 32. Okay. So I'm going to put a star on that. We're going to go through and solve that, get X, all that kind of stuff. I'll put a star on that equation because the next time that we come through this problem and do it a different way, we should still arrive at that equation. Okay? And if we arrive at that equation, it tells me the two processes are ultimately the same. So if I subtract 10x from both sides, I get 6x. Well, careful. You could do that, but why add 4? Because
Oh yeah, you can just subtract the negative one.
right, I want to isolate my x's, right? So I'm going to move this 10 over to that side. And I've got negative 4 plus 32 over there, right? So negative 4 plus 32 is 28. Remove another 10.
18.
So it gives me 18. So x ends up being
2.
or 3.
I said 3.
Huh? You said 4.
You said
I said 2. You said 2, and then I said or, and you said 4.
I thought you said 4.
All right. So x is 3. Just verify things, okay? There should be a built-in check for this stuff. Plug in 3. I get 30 minus 4 is 26, right? Okay. Plug in 3 here. What's 16 times 3? Say again? 48 plus 10? 58. What's 58 compared to 26 and 32? Yeah, they're equal, right? The sum is equal to 58. So that is one approach. Now, I've also seen people trying to do this. Trying to look at that angle, and that angle, and add them up to what? 180. That's a viable approach. Okay, that is true. But do we know that angle right there? No, but how can I find it out? Well, let's say we haven't done this yet. Let's say we don't know if that's true. We haven't done it that approach yet. Is there a way?
Oh yeah, the 32 plus 10x minus, well, whatever that says, add those two together, plus the other x, well, because that's missing it.
Well, so I don't know if this, because
It could be anything, bro.
it could be anything, bro, but it's probably not going to be 3, because that's what we're saying x is in this problem, right? Okay, once we've already solved it this way. Because we're already using x, we don't want to, if there's something unknown, we don't want to reuse that same variable. So if I did want to, I could, I want to label it as a variable, I could call it y, but you would want to use something different, okay? And that might be maybe a third approach to use maybe a system of equations here. But I'm going to do this. What should those two angles add up to? 180. And if you know one of them, you know the other one, don't you? Let's say the one on the outside was 60 degrees. What's the one on the inside? 120. How'd you find that? 180 minus 60. Well, that right there is your 60, right? Or whatever number it wants to be. So couldn't I take this angle right here on the inside to be 180 minus whatever that is, which is 16x plus 10. Does that kind of make sense?
Yeah.
Okay. Now, just to verify if that makes sense, if those work, If I added those two together, if I took 180 minus 16x minus 10, add to it 16x plus 10, I'm left with 180 degrees. Okay? Why did I say minus 10? Because I'm subtracting a quantity. Okay, this is because that's in parentheses, it's two objects, right? But when I know what x is, say x is, ended up being 3, right? Okay? That number would be 48, plus 10 would be 58, right? So I want to make sure that when I subtract from 180, I subtract the entire 58. If I didn't change this to a minus sign, I would be subtracting 48, but then adding 10, which is only subtracting basically 38. Does that make sense? Okay? So you need to distribute that negative. So what I'm saying is that this red angle here, if I take 180 minus the quantity, 16x plus 10, add to it this quantity, 16x plus 10. Okay? Distribute my negative through, so it gives me 180 minus 16x minus 10 plus 16x minus 10. Oh, sorry, that's plus 10. What happens to this negative 16x and that positive 16x? What happens to that negative 10 and that positive 10? And what are you left with? 180. So that tells me that I do have the right expression for that angle. Okay? Now, I've got the three angles of a triangle, right? So let's take 32 plus 10x minus 4 plus 180 minus the quantity 16x plus 10. And those three angles should add up to give me 180. Would you agree with that? Okay, now I'm going to distribute here, so I get 32 plus 10x minus 4 plus 180 minus 16x minus 10 equals 180, right? What are you going to do? Okay, you can combine like terms, but is this 180 right here? And that 180 right there? Going to cancel each other out? Yeah? Okay. So I'll have 32 plus 10x minus 4 minus 16x minus 10 equals 0. Would you guys agree with that? Okay, now, kind of doing things maybe different than what you would normally do on your own, but I want to show you a relationship here. So most people would probably went the 32 and the negative 4, combine those, the 180, combine those, move all that stuff over, right? I'm trying to do this kind of so we recognize the relationship between what we've already done, how we've already solved this one time. Could I do this? Could I add those two things to both sides? So I get 32 plus 10x minus 4 is equal to 16x plus 10, right? Are those two things the same?
Yeah.
Right. So when we use the theorem that says the exterior angle is equal to the sum of the two interior angles, the remote interior angles, it is doing the exact same thing as this, but it's skipping kind of that step of having to find that linear pair, that supplementary angle to the exterior angle. Okay? And here's the reason. Here's the logic on it. I'm not going to solve this because you're still going to get x to the 3. But here's the logic. Let's say I give you a triangle. We're not going to do the proof, but this is kind of the algebra that you would go through for the proof of the exterior angle theorem. If I have those four angles, okay, what are you going to tell me about angle 1 and angle 2? Okay, so measure of angle 1 plus measure of angle 2 is equal to 180. Okay, what are you going to tell me about angle 2, angle 3, and angle 4? Okay, so measure of angle measure of angle 2, measure of angle 2 plus measure of angle 3 plus measure of angle 4 is equal to 180. What do you notice about those two numbers right there? They're the same. So what's that tell you about the sums over here? Well, they're the same, right? Okay. When these two things are the same, we always say that these sums are the same. So measure of angle 1 plus measure of angle 2 is then equal to the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4, right? What's on both sides? measure of angle 2. Can I subtract that? Do they cancel each other out? So you're left with measure of angle 1. Measure of angle 1 is equal to measure of angle 3 plus measure of angle 4, which is that angle and that angle, which are the remote interior angles. Does that kind of make sense? Okay. So that is it's the algebra. Now we didn't do a full proof there because I didn't tell you why was 1 and 2 equal to 180. Definition of, linear paraproxy, right? Y is 2 plus 3 plus 4 equal to 180 because it's the triangle angle sum theorem, and then we do substitution, then we do subtraction. But you see the progression of why that is always going to be the case. Angle 1 will always be equal to the sum of 3 plus 4. Okay? And that's why it makes a little bit more sense to use this theorem and use this approach than to try to use the idea of those being supplementary, finding an expression for angle 2, and then taking 2 plus 3 plus 4. Okay? That's a longer way of doing it. Does that, you guys visualize that? Does that help? Okay.
Yeah.
Do you guys have any specific questions that you wanted to talk about from the homework? Any? Huh?
No, I thought it was pretty simple.
Okay, good. I want to.
Okay, you asked me.
Huh?
Asked us.
Yes, I want to know if you had any questions on the homework. You said no, so we won't go over homework. But I want to do these. This is not homework. It's new notes. Is that all right?
Yeah, I guess.
Man, you guys would.